up to this part. From the beginning up to this part. What do you think? What kind of a problem is it?
Basic problem with constraints.
Chapter 3, the transportation problem, right? Okay, so it's the transportation problem that you supply. It's not even a transshipment problem. You have it's transportation, you have like a supply nodes, supply nodes representing those companies and the demand nodes represented by those projects. Okay, so it's a very basic problem that all of you are able to formulate now. Okay. And then they added some additional constraints here. And our focus will be on those additional constraints. Okay, but first, even though it's pretty simple, we need to formulate those basic things so that we know what our decision variables are. Okay, decision variables will be what? Uh-huh. So would it be Xij's, right? Represents tons of cement to supply from company I to project J. Okay. And the decision variables will be these. And the object function, they said they want to minimize the total cost, right? So it's the very basic one. The sum product of the unit cost between each pair and the Xij's. Okay. And then the constraints for the very basic supply demand problem. The total at company 1. So that's a sum of 1, 1, 1, 2, 1, 3, 1, 4. Okay, so the total of company 1's supply to all the 4 projects need to be less than equal to what's available there, right? Same for all the companies. Okay, and then the next set would be the demand. So for all the projects, they will receive what they required. Okay, equal to. And do you guys remember why we had equal to here? Why we can't have less than equal to?
Minimization problem.
Okay, okay. It's a minimization problem. If we have less than equal to, it will all be 0, right? Okay. And we can do this because of what?
Supply is greater than
Supply is total supply, right? Total supply is greater than the total. Is that right? Total. So what's the total here? 1,007. 1525?
Yeah.
Okay.
The demand is 1375.
Okay, 1375. Okay. And total demand. Okay, so we can do this because we have more supply than demand. So we just set those to be equal and we don't supply more than what is available. Okay, so pretty easy. Then let's focus on the side constraint. Look at this one. Okay, company 1 will not supply orders of less than 150 tons for any project. I know some of you will write just like this. Or just X1. Greater than or equal to 150. Of X1 is the total sum. Okay, this is not right. Okay. What this sentence is saying is that you don't have to choose company 1 to supply to those 4 projects. Okay, that's part of our decision, right? But if company 1 is going to supply, then you have to supply more than 150. Okay, I hope you know what to do now. Several times. Okay, overemphasized. This is again a minimum order size problem. Okay, so then what to do? For any project, that means we need to have 4. Okay, we need to have 4 constraints because it's for all of them. X11, x12, x13, and x14. For all of them, this is saying if company 1 is going to supply for project 1, what's the constraint? Greater than or equal to the minimum order size times the y, right? 150, y11, and less than or equal to a big M, okay, times the y11. Same here. M13, Y13, Y4, Y14. And we can go find out what's the big M value by looking at those constraints, right? So it's 1, 1, 1, 2, 1, 3, 1, 4. One value is 525, and the other value you will look at like these ones, assuming these are not, these are 0. The minimum one is 275. Okay, so the maximum value that sorry, we are talking about x11 only. x11 maximum value is what? 450, right? So this would be M11 equals to be 450. 1, 2, I think that's the one we just talked about right here, 275 as compared to 450. 275, 300, to here, 350, right? Okay, so that's easy for the first constraint. Okay, second constraint. Company 2 can supply more than 200 tons to no more than one of the objects. Okay, this needs a little thinking. It can supply more than 200 tons to no more than one of the projects. Is any part of this statement rings a bell to you? Okay, no more than one. To no more than one of the project. Remember at the very beginning of this chapter, we talk about, okay, say for the 4 projects, among the 4 projects, no more than one can be chosen. What's the constraint? Say no more than one project can be chosen. And we use y to represent if we choose one or not. What's the constraint? We have 4 projects here, okay? Some of them less than or equal to 1, right? Okay, so we'll just leave this here and see, okay, here what we're saying is can supply more than 200 tons to no more than one project, which means no more than one project can be chosen to receive more than 200 tons. Okay, so this is helpful. But how do we link to here? No more than project receive more than 200 tons. It's not a minimum order size. Minimum order size is saying that if you choose it, it has to receive at least. But this one is saying, okay, so let's just do it. Okay, so project 1, 2, 3, 4. Okay, so say if this project received more than 200, I'll say 200 plus. Okay, then the other ones need to be less than or equal to 200. Same, you can just shuffle this. If this is greater than 200 plus, these ones need to be less than. Okay, and Same here. Need to be less than 200, less than 200, less than 200, less than 200. Or the last one would be this one. Less than 200. So these are the situations that can happen. And if you look at, just take one of them. They are the same, right? It doesn't matter which one is that. We're going to use this constraint to take care of it. See, only one. Okay, but how do we link it? Look at this part. What's the thing in common for all of them, or the other three? They are all like less than or equal to 200, right? Okay, can we write this one also? Because we don't know which one is it, unless we can write a common formula for all of those projects. There is no way to represent these 4 different situations. Okay, we need to write a common formula that represents all of them, all the situations. So here, these ones can also only be less than or equal to 200, less than or equal to 200, less than or equal to 200. What about this one? This is also less than or equal to 200 plus some value, right? Okay, focus here, okay? Here, this first one, we can write as less than or equal to 200 plus of value, non-zero value. Okay, what about these ones? These are 200 plus 0 value. And this is plus a value that's greater than 0. With this, I'm going just to wipe those out. All of them are the same. It doesn't matter. Because we're trying to just write out the part for x. So for all the, say this is x 22, okay, x 23, x 24, and this is x 21. Okay, so for those ones, we can write x 22 less than or equal to 200 plus 0. x 23 less than or equal to 200 plus 0. x 24 less than or equal to 200 plus 0. What about x 21? Less than or equal to 200 plus a non-zero value. And what's that value? Think about it. What should that value be?
Minus the maximum capacity?
Maximum capacity subtract 200, right? Yeah. Okay, because what are these? These are the right-hand side. So what we are trying to write is the maximum value that x21 can be. Okay, then let's go back to see what's the maximum value x21 can be. We're talking about 21. 21 here, 450, and here, 21. That's the only place that we have 21, right? 450. Okay, so 450 is the maximum value x21 can be. Okay? So this one is 250 here, right? Okay. Then what do you guys think? What's this 0 here? Can we write this as this times 250? And this is 250 times 1. Can we do this way? So for all of those ones that are less than or equal to 200, we just say it's 200 plus 0 times this value here. And for x21, which is above that 200, the one project we choose to receive more than 200 is 200 plus 250 times 1 here. Okay, now you know what to do. What are these values? Those are the y's, right? Okay. 0, 1, 0, 1, right? It's a binary, so we use the y. So here, we do a y1. y21, okay, y22, y23, and y24. And we make sure only one of them will be 1, the other will be 0 by using this constraint here. We're saying that, okay, so y21, 22, 23, and 24. Okay, so we are saying that only one of the y here will be 1. No more than one y will be 1. So that doesn't matter. You can shuffle between these projects, and only one of them will receive. One of them will be less than or equal to 200 plus 250, and the other will be all less than or equal to 200 plus 0. Okay, so this is a kind of like a little different thinking than the problems we covered before. First we came up with this, so we just say, well, this may be useful. Let's just leave it here. Okay, and then we look at the different possible situations and we'll see, okay, is there a way we can write a common constraint? Because otherwise we have to say choose. Did you guys realize that for all the constraints, like the object function, like in the previous quantity discount problem, learning curve problem, we have to write one common, say, objective that covers all the 4 situations that can happen. And here it's the same. You have to write out one common constraint that will cover all those, like cover both situations, which is one is greater than 200 and the other is less than or equal to 200. You have to write that one constraint that's common enough that cover all the situations, but you differentiate between them using a y value being 0 or 1. So either this happen or that happen. Okay, so that's for this problem. We use 200 plus 250 because this is a larger value.
Okay.
So the maximum of x21 can go is 450, x22 is 275, 23 is 300, and this is 350. This question is which value do we use to subtract that 200, right?
Yep.
And we choose this 450 because what? That's the maximum, right? You don't want to restrict. Say for example, in this case, x21 get chosen. But if we set this to be like the 275, which is given by this x22, subtract the 200, then we are limiting this x21 to go. So why do we use 250 here? We have, because this is a constraint that we're going to apply to all the 21, 22, 23, 24. Why don't we look at, say, the maximum value of x21, 22, 23, 24 and choose a minimum, like what we did in the big M. When we identify big M, then we usually find the minimum value, right? But in this case, it's because we want to consider all the situations. What happens if x21 gets chosen? If we are going to use a small number smaller than this 450, then we are limiting. We're kind of like imposing another constraint here. We kind of like put a constraint here saying, okay, you can't go beyond 275. But in fact, you can go beyond that. You can supply more than 275 in total. And the maximum you can go is at 450. But since we use one constraint for all of them, we'll just use the maximum value instead of using the minimum. But you can, for example, you can have a different value here. Right? You can have a different value here. For example, for x22 would be just 75, right? Yeah, what's this one? Would be 100 because the maximum for 23 is 300, right? And this value can go 150? Okay. Okay, so if we don't use a common constraint for all of them, then the value here for 22, 23, 24 can be changed in this way. Okay, I would say this is a more accurate way, like if we say, okay, to solve the problem and limit the feasible region as much as possible, then this second way will be a better way. But if we don't really care, we just want to use one constraint to represent all of them, then use this 250, which is the maximum value. Okay. Then let's look at the other one. Company 3 accept only orders that total 200, 400, or 550 times. Company 3 accept only order that total this. What does that mean? What does this mean? Is this one hard to understand? No? Okay. What does that mean? Let's translate it into math. What does that mean? Company 3. So 31, 32, 33 plus 34. Yeah, so that's other total, right? Need to be 200 or 400 or 550. So it's like this one or this one or this one. Of course it can be 0, right? This might be easy for you to solve now. It's a either or. You choose one of them, right? So what's the constraint? It's kind of, you don't choose, you only choose one of them, right? The total can't be both. So it's the same as among these 4 values, you only choose one of them. No more than one can be chosen. Okay, so what's the solution? What's the solution? Plus 400 y2 plus 550 y3. You choose one of them, right? So what else? y3 that's equal to 1. Okay, so just saying like the total of them will be either 0 or this or this or this. The rationale is just basically the total can only be one of them, no more than one of them. Okay, so you need 2 constraints for this side constraint. Okay, so this is not very difficult, but it's kind of like another way, the other way of thinking, okay, using binaries. Okay, so that's all the problems that I want to cover for chapter 6.